Okay, well, it's a pleasure to have Kristen Buchanan with us. Today she came from Colorado State University to give this talk. I'm very fond of her. She came to the first time I did organize a similar event. She came to give a public talk, so I invite her the second time to provide us with some insight about her research. Okay, so Kristen, really thank you for coming.
Thanks very much, Juana, and it's great that you're organizing this, and it's great that all of you have come out today to see the NanoDays and to see all of the great demos that they have set up outside. So today I'm going to talk about nanomagnetism, and before I start, you're free to stop me and ask questions if I say anything that you don't understand or that you're curious to learn more about, or you can ask questions at the end. I'm going to start out by telling you a little bit about what nanoscience is and what nanotechnology is from my perspective. Talk a little bit about why it's interesting, especially from the perspective of magnetism. And then I'm going to tell you a little bit about some of the ways that we make nanoparticles and some of the ways that we look at what's going on in systems that involve nanoparticles. So to start out with, one of the definitions of nanoscience is based on the size or the structure of the materials that we're looking at. And a nanocluster is somewhere in between a single atom and a bulk material. A bulk material, we have many, many, many atoms that are all organized into some kind of a crystal structure, or it doesn't even have to be a crystal structure. A nanocluster is when we have only tens or thousands of atoms all organized together. And nanomaterials have very different properties in a lot of cases than the atomic or the crystalline structure. How small is nano? Well, to give you a little bit of perspective of the scale, I have a couple of comparisons here. A human hair is about 200 micrometers in diameter, and a micrometer is 10 to the minus 6 meters. So it's 1,000,000 times smaller than a meter. The nanoscale is 1 to 1,000 nanometers, and a nanometer is a billionth of a meter, 1 times 10 to the minus 9. This little guy right here is a typical ant, and what he's holding in his jaws here is a 1 millimeter by 1 millimeter microchip. So on that microchip, there's a whole bunch of little tiny processors, and those are all sort of nanoscale or thousands or hundreds of nanometers in dimensions. And there's millions of little transistors on that chip. So that gives you an idea of the scale. We can look at things at an even finer scale than that. These are nanoparticles right here. There's actually gold and silver nanoparticles in that picture. And those are defined as nanoparticles in part because of the size. So you can see based on the dimensions. But another way to look at nanomaterials is to define them based on the interesting properties that they have. So, for example, when you make silver really small, then you get yellow. Whereas when you make gold really small, then the color changes and you have red. So gold becomes red. So a little bit of history here. If we look back in time, then there's a very famous talk that happened back in 1959 or so. And it was given by a guy named Richard Feynman. And you can actually find a transcript of the talk on the web. And it's pretty easy to follow, and it's kind of interesting. And one of the things that he talked about was the fact that he didn't see any reason why we couldn't take the whole volume, all 24 volumes of the Encyclopedia Britannica, and shrink that down and write all those pages onto the tiny little head of a pin. And he said that the only thing standing in the way of progress was that we needed to develop better tools to do this. And he actually posed a couple of challenges at the same time. He posed a challenge and he offered a reward of $1,000 for someone to take a motor and shrink it down to 1/64 of an inch. So that's the smallest marking on most foot-long rulers that you see. 1/64 of an inch. And somebody actually managed to do that within only a few years of when he set out the challenge. The other challenge that he gave was for someone to take a book page and to shrink it down by a factor of 25,000. That one took until 1985, and a graduate student at Stanford actually managed to take him up on that challenge and wrote a page of The Tale of Two Cities onto onto the size that he had specified. So that one took much longer. And that actually required actually developing new tools in order to try and do things at that scale. But nanoscience has actually been around for a lot longer than that, at least in terms of the effects that we see at the macroscopic scale in our everyday lives. This is a cup that dates back to 4th century AD that's at the British Museum. And what you see here, when it's red, you have the light shining from behind, and when it's green, the light shining from the front. And those two different colors that you see are because there's nanocrystals inside the glass that they used to build this cup. Now, of course, back then, they didn't know anything about what was happening, but nowadays, we can take that glass and look under various microscopes and see that there's nanoparticles that are causing this to happen, and we understand it. Now, in magnetism, if we go back, and one of the oldest books on magnetism was published in the 1600s, and it had this picture here. Now, this is supposed to be a picture of the Earth, because the Earth has a magnetic field associated with it. And he used little arrows to represent the direction that they thought the magnetic field was at various locations on the Earth. Well, when we talk about magnets on really small scales, things haven't changed a whole lot. We still have structures, some of them round, and we use little arrows to represent the magnetic moment as it moves or with different positions around the structure. And so this is a magnetic vortex, and here the spins are all swirling around, and so they have a vortex type structure. So you'll see other pictures throughout my talk that have little arrows on them, and that's what it's meant to mean, the direction of the magnetic moment. So magnetism actually dates back pretty far. In 4th century BC, we have some of the earliest documentations of people talking about magnetic moments, and they discovered that lodestone, they called it, because it means to attract, actually attracts to other rocks or other pieces of metal, especially metals that contain iron. And this is a picture of lodestone with little iron filings sticking out of it that show you that there's a magnetic field actually emanating from that rock there. And the Chinese were able to use lodestone as an early day compass because they discovered that you could actually make something else magnetic by holding it close to the lodestone. And then you can float that on water and it'll show you which direction is magnetic north. Magnets have two poles. We have a north pole and a south pole. Those are labeled based on the north-seeking and south-seeking behavior of the poles. And as most of you probably have learned just by playing with magnets, if you have a north and a south pole, they will attract each other together. And if you have two south poles close together or two north poles close together, then they repel each other and it's hard to push the magnets together. The Earth is a magnetic moment here too, and it's kind of interesting that the geographic north pole is actually a south magnetic pole, and so it's pulling the north-seeking side of the compass towards the geographic north pole, and that's why we call it the North Pole. Magnets occur in a lot of different places in our everyday lives. We use permanent magnets. These are strong magnets that have a magnetic moment even without, or that always have a magnetic moment. And we use strong permanent magnets in lots of different places. You find them in motors and generators, and you can make a very simple motor just with a magnet and a battery, and you can look at this website to figure out how to do that. And this little piece of paper clip here will actually spin when you attach attach it to the leads of the battery. It's kind of neat. And speakers and headphones, they have permanent magnets in them. And we also use permanent magnets to record earthquakes, if you've ever wondered how that's done. Other places where magnets occur in our everyday lives are for storing information. This is a very big one. Almost every one of you probably has at least one hard drive on which you store your information, and those of you who are older have at least one credit card and probably have owned cassette tapes in your lifetime. Those are all examples of magnetic storage media, and we'll talk a little bit more about that as my talk goes on. And magnetic nanoparticles in particular also show up for medical imaging, or medical applications. We use them for an image enhancement and for targeted drug delivery and for cancer treatments. So magnetic hard drives, a lot of us have made use of these in our everyday lives. Well, they actually haven't been around all that long. The first magnetic hard drive was made in 1956, and this is a picture that shows it being delivered. And this big box here is one hard drive in 1956.